Hi everybody, Joe Rao here. For all of the young people who are watching, I'm a meteorologist. That's somebody who, well, forecasts the weather. And as you can see, we're seeing some rather interesting weather. Something we haven't seen too much of this winter season, snow, flaky weather. Now, I have a book here. It is a book that I wrote a few years ago. It's called The Cool Story Behind Snow. Now, interestingly, did you ever wonder what happens to make it snow? Or why snowflakes can sometimes be like fingerprints? No two are exactly alike. And how do meteorologists predict a snowstorm? Now you can become a science expert on snow. This book was published by the fine people in Manhattan at Simon & Schuster, a big publishing firm, and it was illustrated by Dagny Downey. Now, some of these pictures are funny, but some of these are also very illustrative as well in helping you understand what causes snow and other parts of weather, like thunderstorms and hail and sleet, wind. All of this is explained in this book. Now, in just a few moments, I'm going to get back inside because it's rather chilly out here and also rather wet, and we're going to talk about snow, what causes it, and what its relation to other meteorological things like rain, sleet, ice, and hail, and whatever. Again, the cool story about snow, and I'm going to be reading in just a few moments. I'm Joe Rao, meteorologist, and we're going to go back inside and get out of this snow, which we haven't seen all winter, but we're seeing now. See you in a little bit. Well, it was good to be back in a nice warm room instead of being outside in the cold and the snow. Hi again, everybody. Joe Rao, for all of you young people, a meteorologist, a person who forecasts the weather. And today I'm going to read to you from a book that I wrote back in 2015, a book called The Cool Story Behind Snow. Now, this book is published by the folks over in Manhattan, Simon & Schuster. It has been illustrated, that's the person who drew the pictures, by a person by the name of Dagny Downey. Some of the pictures are funny, but others are very illustrative in that they will help to explain to you how snow develops and other weather events such as thunderstorms and rain and hail and sleet and ice. We're going to go through all of this in this book. And by the way, you're watching right now on my YouTube channel. This is a YouTube channel known as Joe Rao Weather. And you could subscribe to this particular channel. It's not going to cost you a single red cent. But on this particular channel, from time to time, when we have significant weather events, I'll come on and give you an updated forecast on what you can expect in terms of the weather. Again, it's all free. So if you're not already a subscriber, please subscribe. We want to get a lot of subscribers on this particular YouTube channel, all of you who are weather-minded and weather-interested. But again, today, kind of special, we're going to be talking about this particular book, reading from this book, The Cool Story Behind Snow. So we'll start off with chapter 1, which I call Water, Water Everywhere. Now, for all of you youngsters out there watching this, has this ever happened to you? It's early on a winter's morning. You slowly open your eyes and you look at your alarm clock. It's almost time to get ready for school. And suddenly your mom comes into the bedroom. Well, you could stay in bed, she said. There's no school today. Why, you ask? Why indeed? Well, Mom says, look out the window and you'll see for yourself. You raise the window shade and you see snow. Snow! Everything is covered in a thick blanket of white. And more snow is falling, hard and fast. It's a snow day! Gazing out your windows at this amazing wintry scene, you suddenly have a thought. Just what makes it snow? Well, to better understand what makes it snow, you first need to know that about 3/4 of our planet, the Earth's surface, 3/4 of it is covered by water. And the oceans hold almost all of Earth's water. In fact, 97% of Earth's water comes from the ocean. And that's salt water. The other 3% is fresh water and is found in rivers, freshwater lakes, and swamps, as well as locked in frozen form within polar ice caps and glaciers. Water is constantly evaporating from the oceans, rising into the atmosphere as vapor, and then turning into very tiny water droplets that form clouds. And this is part of what we call the water cycle. See, the snowman is pointing. Here's the ocean. It evaporates up into clouds and eventually turns into clouds that hold precipitation. We'll get into that word in just a moment, which form rain, which come back down into the ocean. It's a cycle. It's a never-ending cycle. And any kind of water that falls from the sky, rain, sleet, ice, or snow, is called, I just mentioned this word, precipitation. Can you say that word? Precipitation. Every cloud is made up of water droplets, or if the temperature is below freezing, ice crystals. And the water droplets that form clouds are very, very tiny. How tiny? Well, I'll tell you, it takes about 1 million cloud droplets to make just one single raindrop. Think about that. You've seen a raindrop before. We need 1 million cloud droplets that come out of the cloud to make just one single raindrop. So it must take billions of droplets to form one single cloud. Now, on their own, water droplets and dust particles simply float inside of a cloud because, well, they're so tiny and they're so light. But when there are countless millions of them, the droplets collide with each other, clinging together and becoming bigger and bigger and heavier. And eventually, the cloud becomes too heavy, and gravity causes those water droplets to fall back to the earth as rain. Now we come to chapter 2, colliding crystals. Now, we know how we get raindrops, but now how do we get snowflakes? Well, floating high in our atmosphere are very tiny particles of dust. Now, when the temperature inside of a cloud falls below freezing, now that freezing, by the way, is 32 degrees Fahrenheit. So when the temperature gets to or below 32 degrees, water vapor collects on those dust particles and they form very tiny ice crystals. Now, the shape of the 6 arms of crystals form as water vapor freezes onto the ice crystals. Now, these shapes can be plates, they can be columns, they can be needles. Here's an example of needles, water vapor needles, and plates. Here are some plates right here. And these colliding crystals, these crystals collide with each other to help to form what we call snow. Now, do you remember just a few moments ago I was talking to you about how a raindrop forms? Countless numbers of tiny water droplets cling together to make a single raindrop. Now, imagine countless numbers of ice crystals colliding with water vapor, partially melting on contact, and refreezing on the way down to the ground. And in the end, we get a snowflake, which always has 6 sides. The end result of countless crashes with other tiny shattered and melted ice crystals. Now you may ask, well, why does a snowflake always have 6 sides? Well, the water molecules that make up an ice crystal are arranged in a special way, so they always form 6-sided patterns, which we call hexagons. And as they fall to the ground, the various parts of a snowflake encounter slightly different temperatures and slightly different amounts of water vapor, determining the shape that forms as the crystal glows. And as those crystals grow, because of this, no 2 snowflakes can ever be exactly alike. Every snowflake is different. Every snowflake is its own form, its own shape. Now you may say to yourself, well, we have snowflakes in the winter. Can we ever have snowflakes in the summer? No way! Or snow way. Now, have you ever been caught? Now, let's pretend now that it's the middle of the summertime. Let's pretend it's July or August. Have you, during the summertime, ever been caught in a sudden summer shower or thunderstorm? Now, if you have, remember, the clouds in a sudden rainstorm can also rise very high into the sky, sometimes over 50,000 feet. The tops of these clouds are so cold, they can contain a mixture of both ice crystals and supercooled water. This supercooled water is made up of droplets of water that freeze very quickly. And as the droplets fall through the cloud, ice crystals rapidly form snowflakes. But as these flakes reach the lower part of the cloud where the temperature is a lot warmer, they melt and turn into rain. So here's the thing. You can have snow in the summer because the clouds that form snow reach high into the atmosphere where it's cold, but when those snowflakes begin to fall down toward the ground, when it's a lot warmer, then they melt and turn into raindrops. So the next time you get caught in a drenching summer rainstorm, remember that the rain pouring on your head may have started out as snow. Of course, during the winter, the air is cold enough so that the snowflakes can make it all the way down to the ground. And we can have fabulous flakes. Snowflakes are made of water. When the temperature is several degrees below freezing, you can get a lot of snow from just 1 inch of rain. But this can change depending upon other conditions. Now, when it gets very cold, let's say it gets down to like 20 or even 15 degrees. When it gets very cold, the snow becomes puffy and fluffy. It's almost like a fine powder, like sand or sugar. And that kind of snow really doesn't make a good snowball or a snowman. With puffy snow, you might get as much as 20 or even 25 inches of snow out of just a single inch of rain. But again, to get puffy snow, it has to be very cold. Like I said, 15 or 20 degrees. But now, when the temperature is much milder and hovers within a degree or two of the freezing mark, in other words, when it gets to within like a degree or two of 32, the snow tends to be slushier and mushier. And these snowflakes become larger, the size of nickels and quarters. And they're also much heavier because, and more difficult to push around because if you're trying to shovel it, it's tough to do because, again, the heavy nature of the snow. In that situation, when it's within a degree or two of freezing, out of 1 inch of rain, you might only get about 5 or 6 inches of soggy, wet snow. Why do lower temperatures create lighter, fluffier snow? The surrounding air can't hold as much moisture when it is cold. This means that at 32 degrees Fahrenheit, air can hold more water than when it's colder outside. So snowflakes that are larger and heavier because they contain more water, at colder temperatures, the snow contains less water and the flakes are smaller, puffier, and lighter. So what's the best weather for building a snowman? Somewhere in between the two. The temperature should be a bit below freezing, but not too cold, or else it will turn into that puffy sugar snow. And now here's a riddle. A bad riddle, but it's a riddle. What do you call an old snowman? Answer, water. That's because he's old and it's been hanging out for a long time and it's warm. He'll eventually melt. Well, oh well. Anyway, here's the recipe for snowstorms. Now, we all want a snow day, right? So how do we make a snowstorm? The first ingredient in this recipe must be cold air. In order to have a snowstorm, the air must be at or below freezing, from the cloud tops all the way down to the ground. Again, remember, in the summertime, it's cold enough for snow at the top of the cloud, but not cold enough at the bottom where you are. Temperatures are much too warm, so the snow melts and turns into rain. But in the winter, if you want snow, it has to be cold all the way from the top down. During the winter, cold air from Canada is pushed south into the United States by strong winds in the upper part of the atmosphere. We call that the jet stream. The next ingredient is a flow of warm, moist air to create clouds and precipitation. Now, that moisture usually comes from the Gulf of Mexico. Now, you've heard of rain and snowflakes forming from colliding water drops and ice crystals. Well, a snowstorm occurs from colliding warm and cold air. Because the warm, moist air is lighter than the cold air, the cold, dry air, the warm air is forced to rise above the cold air, forming a boundary zone, which we call a front. I'm sure you've heard a term about fronts. If you've ever watched weather on TV, the weather person on TV probably has talked about a cold front or a warm front. You've probably seen on the weather map the different kinds of fronts. And you see the snowman pointing to that, a warm front, a cold front, a stationary front. Now, the leading edge of a push of cold, dry air is called a cold front, while the leading edge of a push of warm, moist air is a warm front. When the cold air, the cold, dry air, and the warm, moist air reach a standoff and don't move very much, the boundary zone between them is called a stationary front. Now, winter storms will usually form along a stationary front when the front bends or wavers. Then the air will begin to move in a counterclockwise direction, forming a storm system. You look at the face of a clock, the hands of the clock usually move from left to right. Counterclockwise is the other direction, moving from right to left. And that's how the air inside of a storm system forms, counterclockwise. Just how strong the storm will get will depend upon how much moisture and energy is available. And in some cases, the storm may become very strong, producing strong winds and heavy snow. Hey, look, I've never seen a storm where, somebody has had to literally hold on to the light pole, or even a raccoon flying off in one direction. But these pictures by Dagny Downey try to force upon you the fact that when sometimes you get a big, big storm, you get a lot of wind, and those winds can become very, very strong indeed. Now, blizzards. Have you ever heard that term, blizzard? You've probably heard people say, "It's a blizzard out there," during a snowstorm. Well, not all snowstorms are blizzards. There are very special cases for you to have a blizzard. When the winds are blowing constantly at a speed of 35 miles an hour or more, and the snow is coming down really hard, falling heavily, then we call that a blizzard. Blizzards are dangerous. I don't want to stress this too much, because blizzards can be such that when you get snow coming down, the combination of snow coming down really hard and blowing straight across in front of you, it can make it hard to see. When you can see for only a short distance ahead of you, that's called whiteout conditions. If we have those kind of conditions, the very best place to be during a blizzard is inside, indoors. You should never, ever try to travel or go outside when there is a blizzard raging outside. Okay, so we're up to Chapter 4 now, hail, sleet, and freezing rain. Now, frozen precipitation can come in more forms than just snow. Many people just say, well, what's snow? Frozen water. Well, not necessarily, because during the spring and summer months, hail can form. Now, what's hail? Hail starts off as a frozen raindrop which gets tossed up and down inside of a cloud by strong winds during a thunderstorm. Collisions with other raindrops, followed by freezing and refreezing, causes layers of ice to form. And it finally gets too heavy, it falls to the ground as hail. Now, hail is most often the size of a pea or a marble, but some hailstones can grow to be much larger, as large as a golf ball or even a softball. Take a look. Here's our friend, Mr. Snowman. Pea size, golf ball size, softball size hail. Can you imagine getting hit in the head with a softball size piece of hail? That'll cause some damage and also can hurt. If you cut a hailstone in half, you'll see rings of clear and cloudy ice indicating the number of times it got tossed up and down in a thunderstorm cloud. Very, very interesting indeed. Let's go now to the next page here, if I can get it to, if I can get it here. There we go. So sometimes during the winter, a layer of warm air will develop in the upper part of the atmosphere. So the precipitation comes down as rain. However, closer to the ground, temperature is at or below freezing. So the raindrops freeze just before hitting the ground, and they fall as ice pellets, which we call sleet. They can bounce up against or hit against the ground, and sleet makes driving dangerous. So if you must travel when it's icy, remember always to fasten your sleet belt if you happen to see those ice pellets falling. Ice storms can be caused by freezing rain. Now, freezing rain is different from sleet in that it falls like ordinary rain until it hits any solid object that's at or below freezing. Then the rain freezes on contact with the object, which soon becomes covered by a thin layer of ice, which we call a glaze. Now, because streets and roadways are usually dark in color, and because the icy glaze is clear, like glass, and sometimes quite difficult to see, it's sometimes called black ice. Now, people driving cars may not see this ice and skid on the road. This is why ice on streets and roads is extremely dangerous to drivers. When freezing rain falls for a long time, thick layers of ice may pile up on trees and power lines and cause lots of damage. Ice storms can be quite beautiful. Here, the artist, Dagny Downey, has drawn that here. You can see what trees look like when they're coated in ice. Yeah, they're beautiful, but they can also be very destructive. And by the way, how does a snowman get to work? Another riddle. And the answer, by icicle. Oh, please. Sometimes it's not a storm that can bring heavy snow, but the wind. When very cold air blows over large bodies of relatively mild water like the Great Lakes, it can pick up water vapor, lots of water vapor, which then freezes into snow and quickly piles up along the shore and near the shores of lakes that face into the wind. This type of wind over water snow is also known as lake effect snow and can produce blizzard conditions and drop huge amounts of snow in a very short time. Here's this diagram here showing the lake effect snow. Very cold air. It passes over a warm water body, such as a lake, and then translates into snow as that air passes out over the lake and on over the ground and dumps lots of snow. And sometimes, again, blizzard-like conditions. There are places, well, like for example, in western New York and Buffalo, they get a lot of that lake effect snow. Now, sometimes thunder and lightning will occur during a snowstorm. Have you ever been out in a snowstorm and heard thunder or seen flashes of lightning? This can happen when the atmosphere becomes very turbulent, rough, stormy, unstable, and the air is rapidly forced upward through the clouds. The effect is similar to a thunderstorm in the summertime, except instead of a downpour, you can get a burst of very heavy snowfall, and that could drop several inches of snow in more than a single hour's time. As a very young boy, by the way, and here you see a diagram showing this, how the updrafts in the cloud cause falling ice pellets, a collision causing static, creating lightning. When I was a very young boy, on Christmas Eve, this is again when I was rather young, Christmas Eve, we had a snowstorm that caused lots of thunder and lightning, and the snow was coming down heavily. That storm is known now in weather annals as the Donner and Blitzen snowstorm. Anyway, in the United States, large amounts of snow can be found in several different places. Lots of snow falls in parts of the northeast United States and also around the Great Lakes, as well as out west in the Rocky Mountains. The least amount of snow falls in Florida and along the Gulf coasts of Texas and Louisiana. In these parts of the country, it's too warm usually for snow to fall for most of the year. And as a result, snowfall in these places averages only about 1/10 of an inch. That's on average per winter, and very often there are winters when no snow falls at all. But snow has fallen in all 50 states of the Union. It can even fall, believe it or not, in Hawaii. A lot of people think of Hawaii as a nice, sunny, warm place, but in Hawaii, this can happen only in places that are very high up. It might be 80 degrees on the beach in Honolulu. At the same time, on the tops of the highest volcanoes and mountains of Hawaii, the big island of Hawaii, snow may be falling at that very same time. So we pretty much come to the end of the book. Now, the rest of this book gives you an idea of some interesting facts and statistics. And also, at the end, you can actually take a test and answer questions. But once you come to the end of this book, you would be an official science of fun stuff expert on snow. And so the next time you're home enjoying a snow day, remember the science that's behind all the fun. Just give you an idea of just some of the things that you can find in the rest of the book. The biggest snowflake in 1887 fell at Fort Keogh, Montana. A snowflake as large as 15 inches fell to the ground and splattered when it hit the ground. Can you imagine a snowflake that big? But that's the all-time record for a big, big snowflake. We've had snowflakes around here about the size of quarters and silver dollars, but nothing like a 15-inch snowflake. Anyway, if you'd like to get a copy of the book, if you'd like to purchase a copy of this book, you can go to Amazon.com. You can get it either in the hardcover version, there's also a softcover version, and you can also get the digital version for those of you who want to take a look at it on your iPhones or on your computer. Again, the book is published by Simon & Schuster. I'm the guy who wrote the book, and the guy who did the graphics and illustrations, Dagny Downey. And I think it's a very, very good book if you want to know about everything that you need to know about snow. It's again, a great book, especially if you're into wintry weather. And if you enjoyed seeing this, boys and girls, and you parents as well, right here on my YouTube channel, and if you haven't done it already, please subscribe to the YouTube channel, Rao Weather. And here on my channel, my weather channel, along with occasionally reading a story for the young people out there, we'll also be providing you with the latest forecasts during times of important storm situations, and maybe even when it's not so important. Maybe when you want to know if it's going to be bright and sunny for an upcoming weekend, we'll tell you that too. Anyway, I want to thank all of you for watching. Again, my name is Joe Rao. I'm a meteorologist, and I want to thank all of you for tuning in right here on Rao Weather. And maybe sometime down the road we'll have another book. I've written other books. Maybe we'll do something else this next time on astronomy and space. Thanks very much for watching, and take it easy, and you have a good